Hello, this is Mr. Mac, and this is a video about set theory and probability. This will cover session 1. Now, we want to start with sets themselves, and so I would draw your attention down here to the definition of a set. A set is a well-defined list or collection. Now, it says a collection of objects. Objects can be letters, shapes, numbers, actually ideas or events. Now the members of the set are called the elements of the set. Now, one of the ways we look at sets is using Venn diagrams. Now, Venn diagrams are sometimes called Euler diagrams because Leonhard Euler used them a lot, but mathematician John Venn really did a number of papers about sets and set theory, and in them he used Venn diagrams extensively, and so they've come to be known as Venn diagrams most of the time. But don't be surprised if you get an IB test in a couple of years where they call them Euler diagrams. Now, it becomes important, especially in probability, that for our Venn diagrams we have this rectangle that you see on the outside. The rectangle represents the universal set, which is the set of all possible outcomes or all possible things that we're looking at the moment. It's never right to consider the universal set to be the set of everything, but it's at least the set of everything that we're dealing with at the moment. And then a lot of times we will use circles inside the universal set to represent different sets, like set A and set B. This first circle right here might represent the elements of set A, and this might represent the elements of set B. Now notice, when we're talking about sets like A and B, they turn out to be subsets of the universal set. Now, a subset is any set that contains only elements from the other set. It can contain all of them, but usually it contains less than all of the elements. So we'll draw the pictures like that. Now, there's some notation really here that you should be aware of. Sets are denoted using capital letters, usually set A, set B, set N for the set of natural numbers, set capital Z, the set of integers. The names, objects, or the names of the objects or elements of the things that are in the set are ordinarily enclosed by set braces. Now, I'm fond of calling them mustachios, because if you look at a set brace and you turn it on its side, it kind of looks like a mustache. But I'm just joking with that. And you probably don't want to say that out loud when you get to college. Call it a mustachio, because they might make fun of you. But anyway, that's me. Now, this symbol right here, I'm going to make a little pointer here. This symbol right here is a very important symbol. It's the symbol that says something is in the set. For example, if we have the set A, let's just do this quickly, and let's let it be the set 1, 2, and 3, then we could say 1 is an element of set A. Now we would say 4 is not an element of set A, because notice 4 isn't in the set. Now, if we have a set that contains no elements, we say that it's the empty set. And we can use an open mustachio with a closed mustachio, nothing inside. Or, oops, I don't want to move this. I want to move this here. There we go. Or we can use this empty set symbol here. Now, you need to be careful. IB students have a tendency to make a mistake here. They know that this is the empty set, and they know that this is the empty set. And so what a lot of times they'll do is they'll say, all right, well, I'll just show my teacher that I know both of them. But you see, the problem is this is not the empty set. because you have a set, and in it, it contains one element. Now, it turns out that the element it contains is a set, and the set that it contains doesn't have any elements, but it itself is something, and so that would not be the empty set. And this is a mistake I find IB students making a lot more than any other kind of students, because they always want to let me know everything that they know. But this is one case where you got to just put up with either one or the other, but not both. So watch out for that. Now, sometimes we'll use a system of writing sets that's called set notation. And let me show you an example of this. Here, if, for example, is set builder notation, the set, and we would read it like this. Let me get my little arrow over here, follow the bouncing arrow. You would read this: the set of all x such that, see, that's what this says, this up and down symbol is read such that. The set of all x such that x is less than 2 and x is greater than 1. That would be the set builder notation way of talking about the set, and this bar here would be read as such that. Now, the bar is not exclusive. Sometimes instead of a bar, what you're going to find is, oops, here, let me just, there it is. Instead of the bar, there might be a colon there, but we read it exactly the same way. The set of all x such that, and then go on from there. Okay, now, sets are just well-defined collections of things. They even could be ideas or things that have happened or something like that. A lot of times in math, though, we get talking about sets and we immediately think about numbers. Now, since the set is well-defined, let's see, where is that? Since the set is well-defined, what that means is it's important to be able to tell what is in the set and what isn't in the set. So when we talk about sets of numbers, once again, give me the arrow here, there we go. When we talk about sets of numbers, there are some sets of numbers that are well defined, but they need to be well defined to use. So you need to know what is in the set of natural numbers, and you need to know what is in the set of integers, and you need to know what is in the set of rational numbers. So let's just go over this again. The set of natural numbers is the set starting with 1, and then 2, and then 3, and then 4, and so on like that. In other words, another name for this set is the counting numbers. Now, if the set is well defined, then you can tell what numbers are in the set and what numbers aren't in the set. Now, I've shown you that 1, 2, 3, and 4 is in the set. So is 7 in the set? Well, yes, it is, because the ... means and so on and so forth in this pattern. And after 4, you would go 5, and then 6, and then 7. So 7 is in the set. Now, if I were to ask, is 2.5 in the set? It is not in the set of natural numbers, because that set of numbers, the natural numbers, is a set that is being listed or delineated, you know, 1, 2, 3, 4. Now, 2.5 would be between 2 and 3 on the number line, but since we're going from 2 to 3, we're not including the numbers in between. Now, the set of integers is set ... -3, -2, -1, 0, 1, 2, 3, and so forth. It's important to know this set as well. I'll belabor that point times in the past, so we won't go over it again. And the set of rational numbers. Now, it's important to know the set of rational numbers, but the rational numbers, we can't just kind of list them. And so instead what we do is we use set builder notation. Usually we use a Q to stand for, oh, by the way, we use a capital Z to stand for the integers. We use a Q to stand for the rational numbers. And we use set builder notation. And we say the rational numbers is a set of all A, I can do this, set of all A over B such that A and B are elements of the integers. And of course, B is not equal to 0. An easy way to say this would be that the rational numbers are the set of all ratios of two integers. Now, I'm going to pause this video and I'll come back and pick up here. Hi, I'm back. Okay, let's continue now. We have some examples here, and it might be a good idea if you paused the video and answered or tried to write down on your packet the examples 1, 2, 3, and 4. Now, after you finish that, go ahead and continue this video, and I will tell you what they are. Okay, a little music. Da, 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 da. Okay, and we're back. Okay, now you have taken these 4 examples and you've written out what you think the answers are. So the set of positive integers would be 1, 2, 3, 4, ... In other words, positive integers is just another name for the set of natural numbers or the set of counting numbers. Right, the set of prime numbers less than 20. Okay, 2, 3, 5, 7, 11, 13, 17, 19. That's the set of prime numbers less than 20. 3. If set A equals all even numbers, is 3 an element of A? Well, since 3 does not meet the definition of the numbers in that set, in other words, the numbers in that set need to be even, then we would say no, 3 is not an element of A, or 3 is an element of A is a false statement. And number 4, list the set F, which is the set of all x, such that x is odd and 0 is less than x is less than 10. Okay, so we would say F equals 1, 3, 5, 7, 9. That would be the set F. All right, I see someone else in here, and so I will continue. I'll pause this now and we'll continue this a little bit later.